For the second part, we invited Vera. Thank you so much for joining us. And Vera, I met you here at the Weekly Wednesday from Suda, where you were sharing how machine learning at the edge works. And this is also in the Netherlands a very important topic because it allows for much more privacy. The less data goes over the line, the more you can protect privacy. And I was really amazed by your story about how much is already possible.
Manan, I'm sorry to interrupt. Can we stop the recording and start again? Otherwise, it will become too big a file. Can we stop it? Yeah.
I can cut it afterwards. I always do that.
Oh, awesome.
Yeah, no problem. I cut it in half.
Yeah. Okay, thank you.
And then I'll send you the link. No problem.
Thank you.
I'm too afraid to do something wrong, and I don't want to miss the recording. So welcome, Vera. I also was triggered by the what we just talked about, that machine learning can also add to security at the edge. I don't know if you can share something about that as well. Shall I just let you start and introduce yourself and maybe share your story? And everyone, do ask questions. That's what I learned at the Weekly Wet. Interaction is very important, and there is room for it. So put your questions in the chat. It makes it much more interesting for everyone, and especially also for Vera.
Sounds good. Yeah.
Floor. Yeah.
Yeah, it was a pleasure. And thank you so much for having me here. And thank you, Renuka and Roxy, for providing such an excellent primer, I should say, to the conversation and to my presentation. Okay, couple of things. First, let me start sharing my screen. And all right. And just one suggestion I'll make here. So I do have a bit of a talk, and but I want to make sure that I don't overwhelm you guys. So my suggestion is let me kind of present a few things that I had in mind. In the meantime, if you guys have questions, please feel free, just to note them down, put them in the chat, and we'll make sure to leave an abundant amount of time, for Q&A. But I think by just, running through the presentation first, I might preemptively answer some of the questions. This is one thing. And another thing that, having all the questions in the chat will allow us to group them to make sure that we answer as many questions as possible. Does that sound good? All right. Yeah. Awesome. Yeah, so my name is Vera Serdiukova, and currently I work as a Senior Product Manager AI at Salesforce. Previously, I was with LG, Bosch, and a couple of less known companies, but essentially I've been building products with Edge AI capabilities since 2014. And I've seen companies toy around with Edge AI capabilities with a couple of different scenarios. Some of them never actually going to production, never making it. And other scenarios where Edge AI really turned into transformative experiences, business and technology experiences for the companies and for the products. A small disclosure here, at this event, I'm not representing, either my current or past employers. So all the opinions are my own, but I'll be happy to share the things I have seen over the years to make sure that all of you can actually take some useful takeaways from this event. All right, to a man with a hammer, everything looks like a nail. How many of you have heard this adage before? Feel free to put emotions in your Zoom boxes or just raise your hands. To me, this is a perfect idiom describing perhaps tech industry in general and the stage of Edge AI in particular. Solution looking for a problem, right? That's what all of us see way too often. And with Edge AI becoming kind of a new panacea, what I want to talk about today is how to decide whether Edge AI, and specifically learning or training at the edge as a newer, emergent part of it, is the right decision for your product and your business, how to make this decision, and how to achieve the perfect execution of it in your specific product. So to answer this question, we'll talk about a few different things today. First, actually, the decision-making process or framework, the things to pay attention to, and the very practical advice on how to build an application around edge learning capabilities. But before we jump into it, let's just make sure that all of us are on the same page. So luckily, Renuka set the stage here, right? As she talked about different definitions of edge. So in this talk, by edge device will mean a device whose compute, memory, and energy resources are constrained and cannot be easily changed. And by learning at edge, we mean training or retraining of a machine learning model on the edge device. And that's an important distinction, right? Learning versus inference. So in my talk, I'll be covering primarily learning as a less obvious part of edge AI. And I know that many of you already have experience with inferencing. So I hope this one, learning, is going to be a more interesting aspect to cover. All right. Sorry. Okay. So many of you have Edge AI background, and it's not a big surprise for you that Edge AI is frequently touted for its fast and secure operation, its ability to keep data locally. With learning at the edge, all of those, perhaps except for speed, are true. So edge learning allows us to build products that can adapt to distinct and unique user environment or device data locally, with the data never leaving the device. However, many can argue that these qualities can be achieved with more traditional ways of training machine learning models, such as, for example, on the cloud, right, or on-prem. The difference here, and I call it the superpower of learning at the edge, comes really at the intersection of those qualities, where all of these adaptive capabilities can happen while preserving user privacy. And this is really something to kind of keep in mind, the very unique value proposition that you can form by employing learning or training at the edge. And just to clarify, I use learning and training interchangeably. That's the same thing. So that sounds amazing, but how do we actually decide whether learning at the edge makes sense for us? And here, let me ask you this. How many of you are familiar with the should I, shouldn't I game? Okay, it looks like not many. So I was introduced to this game a few years ago by a teacher friend. And essentially, it's a game for middle school kids, allowing them to make decisions for different social situations. So today, we'll be going through a somehow similar experience that will help us decide, whether edge learning is the right choice for us. But before that, let's just set the ground and clarify what goes under learning at the edge umbrella. And roughly speaking, there are three big buckets. The first bucket is what we call model refinement. And this is by far the most common type of learning at the edge. What it does is that you have a central model that you send to your individual devices. And later, this model is updated or fine-tuned using the unique user or device data. The second bucket is what we call collaborative learning. Perhaps the most popular, famous representative of it is federated learning. This set of techniques is slightly different. So you have individual model data that is generated on devices within a network that are then sent to be reprocessed into a unified joint model that is later on shared with the network of devices. And ultimately, you have perhaps the most intuitive, yet the less used approach, that is training exclusively on the edge device. And this is by far the most demanding, resource demanding technique. Also, that kind of explains why it is, not as popular as the other two techniques. All right. Looks like we have abundant options, right, to do training at the edge, and the value it brings is also really compelling. But how do we actually decide, whether it's the right fit for us? The first question to ask yourself is whether the target device, the edge device, actually fits the requirements learning at the edge would impose. The thing is that training tends to be a way more resource intensive process than inferencing. So think memory, compute power, all of those will, the requirements of all of those will be way higher than for inferencing. Of course, the specific requirements will depend on your application, but just to give you a couple of examples of devices supporting such applications. So think, for example, Jetson Nano, or smartphones such as, for example, iPhone 11 or Pixel 2 and up. So all of those are pretty powerful devices, right? Again, it does not mean that, if you don't have this level of compute, edge learning is a no-go for you, but it might give you a benchmark. So at least you should know whether your device will pass the threshold of your training requirements. Unless you have this clarity, I would say going for learning at the edge is a bit of a kamikaze move. So I would not recommend doing so. You might be in a lucky situation where you actually have a freedom to pick your own hardware, right? Or even perhaps go a co-design route. What I mean is that you co-design software and hardware. That's a really luxurious situation to be in, but if it is really your case, one thing to be aware of is that that might impose a pretty high BOM, so bill of materials. An example I like giving here is that, for example, if you think of top-of-the-line smartphones, right? And a specialized SoC, system on a chip, that would be capable dealing with your machine learning load can account for up to 7 to 10% of the shelf price. Okay, that's quite a bit. Again, it should not necessarily preclude you from making the decision, but that's an important consideration to make. Can you as the business, or can your customers actually tolerate this price? If yes, good for you. If no, then an alternative you can go for is, going with traditional cloud training and then distributing the cloud cost through, for example, a subscription business model, right? Just to kind of absorb this cost gradually, as opposed to having a bulk upfront. All right, but let's say the cost is not a problem, and you have a powerful enough device to handle these jobs. So the next level of consideration of this framework is data. So if you remember, when we described training at the edge, we said that with training at the edge, the data does not leave the device. That is a huge advantage of it. The trade-off, though, is that the data in traditional machine learning, we usually have data from multiple users, right? Here, you would most likely have data from a single user or device. So while your data requirements will vary depending on the application, for example, if you are dealing with object classification, right? And you do model refinement, you might need just 3 to 5 images per class. However, if you are doing training from scratch on device-only training, you might need thousands of images per class, right? So the requirement per se would be different, but you definitely need data. And another keyword here is qualifying training data. Of course, again, with data not leaving the device, you will have pretty limited opportunities for data pre-processing and labeling. So this is a thing to think of. Unless you have this data, you will need to find ways to obtain it, right? What it means is that, for example, if you need image data, but your device doesn't have a camera, acquiring this data might be a challenge, right? And as we know, no data, no training. So unless the qualifying data is there or you can obtain it, training in the edge might not be an option for you. However, if you put a check mark here, data done, the next thing to consider is tooling. I mean, I'm sure many of you know that Edge AI is still a pretty emergent field, right? And the technology stack for it is quite, isn't in its infancy, I would say. That is particularly true for training at the edge. And while we see signs of tech stack picking up, so take, for example, Caramel or Corel, the capabilities are still pretty limited, for example, to specific types of the models, right? TensorFlow has been teased in training for quite some time, but for now it is still limited to just one example, like very limited model personalization example. So unless the tools available off the shelf satisfy your needs, you'll need to have the expertise, right? The corresponding expertise within the team. That, of course, might require a bit of an investment on your side. If that is not met, then yeah, perhaps just for the tooling reason, that's a bit too of a risky endeavor. And again, going with more established cloud infrastructure would be a safer bet. However, if that is also checked, congratulations. Good for you. It sounds that learning at the edge might be a good fit for your product, and that's awesome. And I really mean it. The reason is that the biggest reason is that can lead to really tremendous savings. And when I say tremendous, I really mean so. Like for any business, that's really something very, very palpable. Simply because you won't be using cloud infrastructure, right? You will be outsourcing these compute heavy jobs to the network of devices, and that can really save you a lot of cash. So that's good news. But also importantly, you can provide this very unique value proposition to your users. The device is capable of adapting to unique and distinct user device or environment data locally, with the private data never leaving the devices. And that's really valuable, right? Especially in the world we're living in. And this value is increasing with every month, year to year. All right. So now we know how to decide whether learning at the edge is the right fit for you. And I already see a few questions in the chat box that we'll address shortly, but I think I already can answer a few of them in my latter parts of the talk. So let me get through it, and perhaps a few of you will already get your answers right away. All right, so say you figured out that learning at the edge is a good fit for your product. What do you have to take care of? The first thing is to decide what do you actually want to learn through training at the edge. And of course, your motivations will vary a lot depending on your company, industry, whatnot. But I say that people lean towards it in 3 rough scenarios. First, personalization or customization, essentially tailoring your application, your service to the user or user needs or device data. And that's perhaps the most common motivation. The next thing is universal improvement. This is different. That's where you would want to get inputs from multiple users or devices in the network in order to improve overall product, right? Where everybody would benefit from the same improvements. And lastly, independence. Think of requirements for autonomy, right? No network connectivity. That's where you can find value in training at the edge as well. The second question to answer is where and how does the learning happen? And this is actually tightly linked to the first question. Because with personalization and customization, you're likely to make use of model refinement. So think of, for example, Apple Watch. That's what they're doing with the face of the watch that adapts to your usage, right, to your behavior. Universal improvement is slightly different. Here, you might fall back on collaborative learning. For example, here's the case of NVIDIA Clara system for federated learning that was used by multiple medical institutions. And what they did, they essentially used the network of individual hospitals and institutes to train the common model, to ultimately, I should say, train the common model that provided better results in identifying, in reading mammograms, right? And they were able to achieve it by keeping private data local. So they only shared the model updates, not the individual patient's data. Third scenario, ultimate independence. Perhaps the only option here is training exclusively on device. I was truly scrambling to give you guys a good example, but the reality is that I haven't found any. As I said, this technique is so computationally intensive and in many ways not practical because you cannot share your model between the devices, right? So the other devices cannot benefit from the training you have conducted. That, frankly speaking, I'm not aware of any applications of this in real world, like in industry. So if you know any good cases, please do share them with me. Okay, next question, when does the learning happen? And here you really have to think about your user journey. Because you'll have to define frequency, trigger, and device state when to train. By frequency, I mean, do you want, for example, to provide personalization only in the beginning of the user journey, when the user starts using your device? Or do you want to provide a constantly evolving user experience, right? This is kind of the decision to make. Trigger, essentially what prompts the learning process? Is it a part of the user journey? For example, enrollment process into the device, or the achievement of a certain threshold of data? Usually it's really a combination of both. Device state, to be fair, most of the devices are not designed to be running at the top speed at the top capacity all the time, right? It might lead just to overheating, thermal throttling. So a rule of thumb is, for example, to do training when your device is idle, when it is charging. So that's something to take into account when you design your application. And the last important consideration is the role of your user in the training process. And this is also linked to the type of application you have in mind, how visible it is to your user. Is it implicit? Is it explicit? What I mean by that is that if the application is, you can involve user very explicitly if the application is visible. For example, have them as a human in the loop helping you to label the data. Or it might be implicit role, passive role, where the user, for example, just produces the data you'll be using for training. Or perhaps the user doesn't have any role at all, because you're actually learning from the device data that is independent from the user. So here it really depends on what you're trying to build. Okay, I see that there are quite a few very practical questions. I promise I'll get to them, but I'm sure that this section will actually help you understand the general rules that will most likely already tap into a few of your questions. So so far we've been theorizing, right? We've been talking about all these frameworks and rules. Let's get our hands dirty. How do we actually build an application with edge learning capabilities? The first step, no matter what your pipeline is, make sure you have the data, right? And like I said, with data not leaving the device, you have to be very intentional about it. You might need to design new frameworks, such as, for example, Siri has the enrollment process, right? Specifically to obtain the user data. Or the data might already be there. For example, your user might have already taken thousands of pictures that you use for training. However, one thing I would recommend, no matter what you do, make sure that you are very transparent with your user. What data is being collected and what this data is going to be used for. Be honest, and this will build trust. The second thing is you might need label data. And again, depending on how visible the application is, you might either directly prompt your user, for example, type in the name of the person on the image, if it is a photo sharing app, right? Or it might be more implicit, such as, for example, collecting signals on the user interaction, or, for example, connecting user data to the existing profile, right? But very likely you'll need to create some attributions for your data. Next, depending on how you answered the timing questions, remember frequency, trigger, and device state, right? You might need to give your user a power to control training process, meaning launching, pausing, or seizing it completely. So design for that. Next, Chris, so the thing with things happening at the edge, both inference and training, especially training, since it is a more private process, you as the developer, as the application owner, have less transparency, less visibility into what happens on the user device, right? And how the model performs. So it is a good practice to mark the results of the model update. For example, again, back to our example of a photo sharing app, if the pictures were classified as one class, for example, they were marked as, they recognized it as you, and then you retrained the model, and now it recognized that some of the pictures were mistakenly classified as you, but it's actually somebody else. It's good to mark them, right? And to show that, okay, now inference result has changed, just to inform your user. And this is actually tightly linked to the next point, course correction. Again, with less visibility, you just need, as a developer, you need to make sure that you build the guardrails, right? That you build those fallback scenarios. In case your model does not perform well, your updated model does not perform well. Here is the example of Gboard that I just love. So it does, by the way, it uses federated learning, right? Training at the edge, but it also gives user alternatives. You can also just, first it gives you a few results you can choose from. Plus, you as the user can always just go for the manual route. So that's a good practice, right? While you, of course, hope that your model will perform well, you should build those guardrails to give you the options. also potential to let them inform you that the model is not performing well, or even perhaps roll back to the previous iteration of the model, or who knows, a non-model approach to solving the user job to be done. I know that's a lot of information, but hopefully what we have done here is I've laid down the framework for you to decide whether learning at the edge is actually something you should get yourself into. And that's so that's a potentially a really high return option, right? But you have to be intentional about it. And also we have shown what it takes to actually build a brilliant implementation of an edge learning enabled application. I hope that helps. And yeah, I'll be happy to answer your questions now.
Thank you so much, Vera. This is really enlightening. I love your, I told you the last time, the framework you present makes it so transparent and so simple for people to follow, and not to make the, not to follow the hypes, but really choose based on the probability that you will succeed in the end in building something. It is Sudha asked us in the chat what is the most applied form of machine learning on the edge, I think. Mm-hmm. You know the answer, was it the typing support?
So I would say in terms of the technique specifically, that's definitely model refinement, hands down. And for those of you who might be experimenting with learning at the edge, I would say that's also where you see the tooling, right? Yeah, so there are tools emerging that actually allow you to automate these processes. In terms of the domain, it's been changing. So I would say in the past, it actually started primarily with audio. So, like I shared this example with Siri, we saw that a lot in biometric voice authentication, and that started emerging already, I would say, 10 years ago, with traditional machine learning techniques. Now I see more and more in the fields of CV computer vision. That might be related with, CV just picking up more steam in the industry overall. But I would say both audio and image-based classification and perhaps occasional anomaly detection are the most common use cases I see.
Yeah. Marco, I think you can also ask your question live. Just unmute yourself. That's a bit nicer for the discussion.
Yeah, sure. We've recently had a machine learning project within our company. And what strikes me most is that the people working on the data sets are data scientists or developers. They don't necessarily have domain expertise on the particular domain with which the use case you want to solve a matter. So how can you make sure that the data sets that are acquired really add up to solving the use case?
Right. That's an excellent question, Marco. And, I wish I could say that it's a unique problem, but unfortunately, I have seen it so many times, right? And I think there are a few kind of rules of thumb. One is that it helps when you are clear on the problem you're trying to solve. Of course, a lot of times what happens is that you have a stakeholder or customer come to you saying, hey, we have data, right? Help us make use of it. And what it leads to is that first of all, a lot of times, this data might not be really good for anything. Two, you don't have like clear business objectives. And three, and usually it's a combination of a few, right, things, is that people dealing with the data, right, such as, for example, data engineers, data scientists, they don't have any domain expertise to actually properly interpret this data, right, and or understand its business value. So I would say focusing on business objective is something that helps just to cut through this noise. This is one thing. Another problem I see is that a lot of times data science exercise or machine learning exercises start with public data sets. And I mean, that's natural, right, of course, of one thing is kind of the training, right? That's what people do in universities, doing their master, their PhDs. Another thing is that a lot of times public data sets provide the amounts of data, annotated data, importantly, that you might not have within the company. The reason I find it to be a problem with that, it's not a big surprise that many, if not most, of the publicly available data sets have major bias problems, right? And this creates kind of a vicious circle where on the one hand, you have generations of professionals, machine learning and data science professionals, just being used to that and taking that for a normal situation, while it is not, right? And it creates multiple business, image, and ethical implications. And two is that public data sets actually might be used instead of proprietary data, and at least to build initial problems. And the reason that is a problem is that might have implications on the quality of your ultimate model and the ML powered capability, and not to mention this introduced biases and whatnot. So I would say that's a really multifaceted problem, and I definitely can relate to it. And my suggestion is really to be very sharp focused on the business objectives and understanding what data you need to address this business purpose, and how it can be obtained from your business or your customer, and really working with domain experts. Yeah.
Maybe I can give.
Thank you.
Thank you, Marco. Also an example, your last sentences triggered me, because I have a friend who's training systems to use against poachers in wildlife parks. And he was also training them on gunshots. And what they did, they used a database of sounds that Google provides. And that had a really bad result. And then they started to listen to the sounds in the database, and it was a lot of cartoon pew pew pew, and a lot of blockbusters with gunshots. So it wasn't original gunshot. So apart from the bias we were talking about, you also have different perspectives on what is the data that is needed in this case.
Right, the quality, right?
The quality, yeah. The
Yeah.
quality, yeah. I also have a question from Sudha. Because there is this trade-off if you're transparent about and asking permission to use the user's behavior data, it might also influence that data, because then they will react on knowing being monitored. Do you recognize this in practice, and how can people deal with it?
That's a good point. Frankly speaking, I think it really depends on your application. And what I mean by that is that, again, what exactly do you want to achieve, right, with this capability? And I'm not talking just about machine learning. Machine learning is just a tool here, right? But in general, like, what problem do you want to solve for the user? This is one thing. Two is how this training is going to happen. As we mentioned, is it a one-time thing, or is it a consistent process across your user journey, your user's user journey? So there are a few factors to count in here. So I did observe it, for example, in some of the biometrics cases. For example, when either facial biometrics or voice biometrics, the data were connected. And for example, a few samples of voice would be collected to form the voice signature, so to speak. And in some cases, you could tell, not for everybody, but in some cases that, for example, the voice speech changed. But I would say there are pretty good tools in machine learning to account for these potentially noisy data, right? First, you might need to collect a few samples to really mitigate this. Second, you might need just to create, it's more of a UX exercise, right? But the process, for example, the enrollment process, the data collection process, that would ease the user, right? That would bring them into their natural state. So it's more of, again, a UX problem than a machine learning problem. And of course, there are also a few data processing techniques to also account for that. So I would say overall, I'm not familiar with the cases where that would really be an impediment. Do you need to design for that? Perhaps, yeah.
Okay. Thank you so much. There's a question for Martin as well. There are a lot of different edge systems, and what is the best way to synchronize them?
That's a brilliant question, and that's seriously, and that's really a huge challenge, I would say, for edge AI in general and for training at the edge in particular. And again, there are a few aspects to it. One thing is that you might develop an application that would be run just on heterogeneous devices, right? So say, for example, a smartphone versus a tablet, like different generations of the phones, right? And that actually ties more to also traditional software development, right? Where when you build an app, you don't know whether your user is going to be running it on a $100 smartphone or the newest generation, right, of an iPhone or smartphone. So that's, I would say, a traditional challenge. Just here, the tip of this challenge comes into the requirement, the resource requirement, so compute, memory, things like that, right? That might limit your application only to more, for example, top of the line, more expensive devices. So that's the challenge. The second part of it is that your user might have multiple devices, right? And say the model is trained on a specific device. So for example, again, a user has a laptop, a smartphone, and tablet, right? And for example, they use your application more on the phone, and the model is trained on the phone. But then occasionally they also use it on a tablet. But if the data stays on the device, how do you transfer the same experience to the tablet, right, for the same user? So it is a challenge. There are a few tricks to counter that, but that's definitely something to have in mind. And here, what helps is really to have a solid understanding of your user journey and multi-channel experience. Do you want to provide the same experience on multiple devices your user owns, or is it more of a device-specific experience? That might also be, a very specific value proposition, right? Of course, smartphone-specific experience might be different from a laptop-specific experience. So depending on what you're trying to do, have the same kind of the same experience or more tailored experience for different devices.
When we talked before, I think around a month ago, you mentioned also that you can train on the edge, but you can also train the model. Does that relate to what you were just saying? Because if it's better trained on the phone, how do you optimize the model on the laptop as well, based on what it has learned on the phone?
Right. Yeah, absolutely. So that's exactly the point. Is learning at the edge essentially allows you to customize and tailor, right? But one thing you'll need to a design decision you'll need to make is that whether you want to tailor to the user period, or do you want to tailor to the combination of user and device, right? Where the experience will be different for different devices the user might use, or also the environment, right? So for example, you have the same user, but they might be using your application, for example, in the car and at home, right? On different devices, or perhaps same device, but again, different environments. So learning at the edge also allows you to account for that, to create a unique experience for the environment. But is it something that is relevant, to the experience you want to provide or not?
Yeah, Sudha was also asking, how do you involve UX designers in this user engagement?
So if I may jump in, sorry. find that fascinating that you said that we should get the user to be aware of using their data. And so I was thinking in the design process, are you seeing UX designers, because UX designers care about what you communicate. The trust factor is controlled or managed by the UX designers. So I wanted to know what you're seeing about the role of UX in doing EdgeML.
Right. Yeah, so one thing to say, I'm biased here, right? Because I come from a product background, and for me, UX designers are really partners, right, on pretty much every step of the journey. So that's a huge part of just understanding the user needs, understanding the context they operate in, understanding how to build the application to address that best. So I mean, I know that we have audience from very different backgrounds and, you know, from different walks of life and coming from companies, very different resources. What I find is that having a qualified UX person early on this journey is incredibly helpful. It just helps to preempt so many things that you would need to fix later. So that's one thing. And so that to your question on the role of UX designer in addressing the data and user the user information aspect of it. So yes, definitely, because informing the user should be a natural part of the user experience, right? And I mean, we see a lot of it being adopted in the industry, right? Every time you download an app on the on any app store, right, it already tells you what data, for example, from other apps or just overall is being collected. So I feel like it's really something that is being generalized in many ways. However, when you make this information available within your app, you definitely want it to be a cohesive experience, right? So that's where that helps. What I find in some companies, that's also a big legal question, right? Especially when it comes to sensitive data. That might be health-related data, like, yeah. Even with the data staying private on the device, there might be really a liability for the company. Again, in the world of the GDPRs and what all of this regulations. So I would say UX person, yes, but again, depending on your environment, having some legal advice might also be useful.
Thank you. Carl, could you ask the question yourself? Would you mind unmuting yourself? I'm looking for Carl now. Carl? Ah, there he is. We still don't hear you. Did you read the question as well, Vera?
Yeah, let me just read it out loud. How do you make sure that the user trains in a correct way? The user basically has to know how in the inference get a good accuracy level, and that requires the right training. That, Carl, that's an excellent point, and I cannot just overstate the importance of it, and that actually is tied to the point of having quality training data. And this is really the point where I would say building the user experience, again, like, you know, speaking of having qualified UX people really helps. So there are 2 points here. I would say first, again, design for data, for collecting quality data, right? So it should not be just like a parallel line to the to you running or designing the app. It should truly be a central piece of you building your application. And what I mean by that is that make sure that it aligns with your goals, right? For example, again, do you need to customize this experience? For example, customize this experience just once, or do you want to build an evolving experience, right? So build that in. make sure that you provide very clear directions to your user. One example that I like to provide, I think that was, please forgive me if I'm confusing things here, but I believe that was Sensory that provided this app that I think it was called Sense ID. Don't quote me on that. What it did, it allowed you to create an ID, like a biometrics-based ID, to unlock your application, so to authorize you for usage of certain applications or data. And I loved the way they designed it. The reason is that what they needed to do is to collect your facial biometrics and your voice biometrics. And while they were guiding you through this process, what they did is, for example, they showed the specific area your face should be in. If, for example, you were in a dark room, meaning that your image might be too dark to read for the system, they would give a notification that your surrounding is too dark. Please get into the light. If it were too bright, again, it would tell you. When you were recording voice, again, if the volume was not there, or if you had some background noise, it would let you know. So that was one thing. But even before that, they preemptively showed you how to do it. For example, they would tell you, please get to the quiet place, right? Please make sure that your device is like in a certain distance, and they will specify the distance from your face. So unfortunately, I cannot pull it up right now, but really look it up. That's really an example of a really well-built way to collect quality user data. You need to educate your user, right? Of course, you're the only ones who know what data is good data. So you need to make sure that you build this very natural experience that on the one hand educates the user, on the other hand doesn't feel like just overhead, unreasonable overhead, but it is doable. I've definitely seen good examples of it. And I guess for many of you, perhaps, iPhone users, you might relate to that with just the Face ID. I feel like they're also doing it pretty well, instructing the people on how to collect good data, and they're using training at the edge.
Okay, that's a real application for training at the edge then.
Yeah.
Okay. Yeah. I've two nice examples. So my Wi-Fi connected weighing scale is being misused by my housekeeper, and every time she stands on it, her rate is not in my average, which is very unfortunate because that would lower my average quite substantial. But so they did it good at their side. And yeah, I once got a training from a guy where we use this classical training model for selecting cats and dogs in pictures. And then at his first go, he first trained all the cats, and then all the dogs showed up as funny cats. Because of training it the wrong way, basically.
Yeah, I would say, again, depending of what just what resources you have, right, and what expertise you have. A lot of these things are offset by the tooling, where you can just take off-the-shelf tools that will help you to build pretty high-quality applications. And that also goes back to the automated machine learning topic that Manan and Sudha touched on, where you might not have deep knowledge of data science or machine learning, and you can already build pretty functional applications. So that's one thing. Another thing is, again, whether you do it with AutoML, just with your kind of more manual skills, there are ways to offset it. Having something like anomaly detection, like in the case of your housekeeper, right? Just the system knowing what normal looks like. And the normal can be not a point, right, but a range. And when something is out of this range, it can either directly detect it, or it can also do some sort of human in the loop thing, actually verifying with you. Does it sound to be right?
Too good to be true. Yeah.
And maybe attach a speaker that will ask her kindly to. put on
So
some
me and my girlfriend, we are still discussing, should we tell her that we know her weight? Because she doesn't know it's a Wi-Fi connected thing with data collection. So it's quite
Speaking
funny.
of data privacy, right?
Yeah.
No,
People
but
don't know.
I mean, one thing to say that, of course, none of those systems are infallible. And if you Google, you'll see all these examples, for example, by people tricking, again, like iPhone's facial recognition, right? Even though I have to say, I really admire, because what they do really well is evolving with the user. For example, you know, it learns when and how you're aging, right? Or changes in your appearance, such as, for example, glasses or you know, facial hair, things like that. But there are hacks, like you can see those things, for example, people's kids, right, tricking the system. Of course, kids just look so much like their parents. So many of these applications are not infallible, but the reality is that pretty much nothing in the world is infallible. There is no model, machine learning model, that is 100% in terms of accuracy, recall, you know, all of those criteria. Again, it's just, again, it's more of responsibility on you as the designer, as an architect, to make sure that you understand the limitations of the system, that you either design the guardrails, or you can communicate those limitations to a user and guide them how to salvage in case it doesn't function as intended.
Yeah, clear. Thank you.
Super. Thank you so much, Vera. This is really, I'm awed again, because you have this talent for explaining things and taking us along the journey in such an easy way, that I really feel that I understand it now. And I think I speak from all of us, that we are really grateful for you sharing this story. Is there any last takeaway because you have shared so many takeaways, but is there a last one you want to share with us?
Yeah, I just wanted to thank you for having me again. It's been fun, and I've really enjoyed all the questions. I hope we managed to address most of them. If something is unanswered, please feel free to reach out over LinkedIn. I'll be happy to continue the conversation. And please don't feel overwhelmed. So my goal here was not, you know, to deter you from using learning at the edge. I really wanted to show you that it has a tremendous value. But just like with pretty much, you know, any technology, and especially emerging technologies, it helps to be a bit more deliberate on how you make your choices. And I hope I was able to show some, you know, good rules of thumbs that I have observed over the years to help you build really functional and delightful solutions for your businesses and your users.
Yeah. Super, thank you, Vera. I think you answered all the questions, but indeed, if anyone question pops up later on, I know you're very accessible on LinkedIn, so please do collect. I think there's only one question unanswered, and that's the question from that Sudha has to answer to the group. So maybe you can come unmute yourself, Sudha.
I'm wondering what question. I thought she answered all my question. Oh, I was just adding. Oh, I was just adding a comment since she said auto ML.
No. You asked about what application was used most.
Yeah. Okay.
So I wondered if you wanted to share the answer.
Yes, thank you. So I just wanted to set the stage for Vera's talk, and so I posted on Twitter last night saying, you know, which is the application that is auto ML, or not auto ML, Edge ML, that is most common used in the world, and there were a lot of different answers, and I think Carl here came the closest. And one of the things I told people is, since I did the No Code AI webinar saying there are multiple live labs as part of my course, I was tempting people saying, I will give you one of those free webinars. I mean, not free webinars, free lab sessions. You answered this right. And Carl does, I have to give it to Carl because he came closest. So what I was going for is, phones, right? And while Vera was talking, she did cover that. So the answer, she gave a lot of examples on the phone, but I was thinking, there is billions of phones out there. If you look at it globally, right? I had people, from my world, they always say self-driving cars and, phone cameras is close, I would say, but I think there are phones which don't have cameras, which are not smartphones, but still phones which will do autocorrect, and they will do transfer learning from our autocorrect and translation and the Google keyboard example she was giving. So I was going for the phone, for auto ML on, Edge ML on the phone was what I was going for. So anybody who ever gave me an answer close enough, I'm going to make sure that I include them in the lab. And my class is set up as 3 labs, so it's like 3 months, and you give a business problem, and we will solve it using auto ML end to end. So I will follow with you and make sure that you get into at least get one.
If you don't have any problems, Carl, I'm sure I can come up with some problems for the class.
Okay. Yeah, and the thinking is it's not just taking a data set and feeding it and creating a model, but you want to take a real business problem, understand how to get to the data and get to the feeding the no-code AI tools, right? It's not just about the tools, but solving the problems. Vera, I just love you. You're so amazing. I actually am so lucky we did this as a joint session with Menon, so I got to hear you again. So thank you so much. Thank you, Menon.
Same.
Thank you, Sudha.
Thank you all, and thank you for also introducing Renuka. It's been very informative for me as well.
Yes, interesting. So thank you, Sudha. Shall we close off? And thank you, Vera, so much. But I'll stay in touch with you.
Sounds good.
So you have the